Hello, everyone. Welcome to another Thirsty Thursday. Mill-Turn Thursday. As you can tell, I'm already looking towards the weekend. That said, today we're going to work on this actual pinion shaft with our mill-turn machine, and I'm going to show you how to use some contouring strategies to both rough and finish out these teeth. So let's jump into it. So as you can see, I already created my setup. I have my XYZ set. I'm going to go in and I'm actually going to turning profile rough because I do have to do the turning portion of this still. So let's go ahead and grab our right-handed tool. I'm actually going to go in and only turn this so far back, and you guys will see why. And the reason for that is because I am going to use vertical passes, and I am going to rough out the front of this part and basically face it off as well as get in here and rough everything out vertically and save a little bit of cycle time and some different things that happen. Now, once you get past that kind of point of, you're no longer going vertical very deep, it's better to go horizontal. So now let's hit this with a turning profile rough. Again, I'm going to use some selections here. Again, this is starting to show you guys the speed at which you can do just strange things inside of Fusion. Again, I'm going to go off this upper chamfer back here, and I'm going to give it an extra 100 thou. In our passes tab, we're going to go ahead and say don't allow radial grooving. I know we're already going to get an issue with that where we would start to waterfall. So I'm just going to turn it off. But as you guys can see, we've now done our OD roughing on this part. The last thing is to actually get this undercut / grooved out area. Most of you are going to go for turning groove. However, yours truly is not. And the reason for that is I'm actually going to use turning profile rough with a grooving tool, right? The idea is that, again, with some selections here, I have the ability to select both my front and my back. Again, I'm going off the top side of that chamfer. Is if I wanted to extend past that chamfer, 0.05 in this case, what you're going to notice happen is we are now able to carry that extension of that chamfer with our grooving profile. A couple other things here you guys are going to notice. I'm actually horizontal passing, and it looks like we're starting way further out than our OD that we turned. So what I'm going to do is I'm going to go in and I'm going to start by fixing the fact that I want to do vertical passes. The next thing I'm going to do is I'm going to go ahead and kick on our rest machining. So now you're going to see those two things be adjusted and fixed. One last tip here is if you are going to use roughing for grooving, make sure when you set your tool profile in your passes tab, depth of cut is now your step over. So if I wanted to go to 100 thou step over, again, I can go ahead and type that in and hit OK. Again, creating that actual chamfer profile and breaking those edges for me. So now that I've done that, is you guys would make a finishing path, but for most of you, you're here for the meat and potatoes of this rotary strategy, right? So let's go over to our milling tab, and we're going to go to multi-axis rotary pocket. I'm going to go ahead and pick my tool. In the case of this, I'm using a bull nose end mill to rough this out. I am going to do a pretty heavy full width kind of slotting technique. That way I don't need a square end mill and I can save those tool nose radiuses. However, I am going to do a lot of selections here. And the reason why I'm going to do selecting versus rest machining is I'm really trying to cut down on my calculation time for demonstration purposes to all of you. So again, I'm selecting my front, my back. I'm going to do a selected outer radius also. And what that is going to be is where my gear teeth profile are. And to think about it, we know that we have turned that all out now. So with that being said, in my passes tab, again, I'm going to bump this up to about a 10 thou tolerance. Maybe I give it a 0.2 step over. And then lastly, I'm going to give it like a 100 thou step down. And I'm going to hit OK. So why this calculates, it's the perfect time to tell you guys, don't forget to like, follow, and subscribe to get the latest update on my videos. As well, go check out my tolerancing video and see how you could speed up these calculations by simple adjustments inside the software. Now, as you guys are going to notice right off the start, we are coming in off of our stock in the front, and we are going to the exact back. Now, for most of you, tangential extension has probably been your best friend up to this point. So what I'm going to do is I'm actually going to go back into my toolpath, and I'm going to go to my passes tab. Notice how there is no tangential extension in this path. However, there is a cutting moves approach. And what I need to do is I need to toggle on the behind back limit. And what that is going to now allow me to do is to extend that toolpath past the back of that profile. So we'll give this a few more moments. Again, guys, I'm going to hit you with that like, follow, and subscribe. But now that our toolpath has came out, we can now see that we are coming in and running those profiles and roughing out in between those teeth using that exact path. Again, we do have a little bit of funkiness where we are doing some moves way out here to the front of the part. I would clean this up more. Obviously, I'm going to do another video on Workflow Wednesday. It is a deep dive into the rotary path. But let's go ahead and switch over and let's now do our rotary contour. So what I'm actually going to do is I am going to derive the one off the other. And what this is going to allow me to do is to go to multi-axis milling and go rotary contour. That said, based on my geometry selections, this is coming through automatically. The one thing I am going to do, again, is have a higher tolerance. And maybe our step down now is going to be, in the ballpark of 50. Again, what I'm looking for here is to get you guys paths on parts to see how easy it is to go in and 3D profile these teeth faces so that you can actually take on, one-off parts like such. Now, I would recommend if this is something you're doing all the time, odds are you have a gear hob. That's a way better approach to this. However, I have seen a lot of companies even grinding teeth. They are actually 3Ding them still prior to heat treat and hardening, as well as leaving stock on those walls to be finished. But as you can see here, very quickly, I've been able to create those teeth profile and 3D them. Again, I am going to tell you guys, you're going to do a lot more step downs. Maybe you're going to use a different tool. Again, I should have swapped out to a ball end mill. But just like that, we have gone through and we have now done the outer portions or the teeth faces based on that. Now, again, we could do this all over again one more time. One thing you can see here is you do have rotary parallel as well for those lower floor strategies. However, I would actually just use that contour again or a scallop kind of technique. One thing I'm not going to actually walk you through, but again, because you would have the machining extension, this is a great time to do a deburr. And in that deburr toolpath, you could do fourth axis deburring to deburr the edges around all of those teeth. So let's wrap up this Mill-Turn Thursday by flipping our part over and going ahead and roughing the other end of it. So what I'm going to do is, again, we're going to say brand new setup. I'm going to go in and I'm going to make sure I'm using from preceding stock. Again, that now flips our part around. As you can see, we still have this material to turn. This is a relatively large part, so I'm probably working mainly in my headstock. Now from here, maybe we hit it with that traditional facing operation. Again, going back to my right-handed tool. As you guys are going to see here, this is a pro tip for you. If you're working on the sub spindle, don't buy left-handed tools, please. Buy just right-handed tools and flip it over, right? Why have extra tools laying around that you don't necessarily need at the end of the day? Now, if you do need a left-handed tool, by all means, please buy left-handed tools. But as you can see, multiple depths. We're going to hit this with an OD rough. Again, I'm going to go to a selected back. Again, I'm using that top chamfer line as my dividing line. I'm going to say 0.1 past that. Again, this will take a quick second to calculate because of all the rest material that it's thinking about using. And now we've done that outside roughing. We can chase that down with the derive. Again, doing our turning profile finish strategy. And just like that, we have now wrapped up the backside of this part. And looking at our stock model, guys, I do have an error here. I know a lot of people ask me about this. If you want to fix this error in this case, we know we're not cutting anything. We could go in and we could say, allow lead to cut stock. And then your error is going to go away and we're wrapping off that part. But as you can see, it relatively didn't take much to actually use rotary pocket, rotary contour to profile something such as these pinion teeth on this part. Now, before I let you guys go, it's not what you know, it's who you know. Again, you guys know me over here at JITCADCAM. I'm here to support you in any way, any problems you have with these toolpaths, or even wanting to purchase your software or move your software over to us. Now, that does help support this channel and creates more content as such. A lot of my content does come from my customer situations and common things that I see in the industry. That said, I'm going to go ahead and leave you guys with it. Have a great rest of your day.